Alright, in this video we're going to look at the problems from our test review that cover the operations with rational functions. In this first one, all we need to do is simplify this rational expression. First step here is going to be to factor. That should typically always be your first step. So I'm going to factor the numerator. K and K, let's see, 80 would be 8 times 10, and I need them both to be negative. And in the denominator, it looks like all I can do there is factor out of 5. So 5 times K minus 10. Let me say here, if you're still having trouble factoring, there's another video on factoring quadratics that you can go back and look at and practice those skills. But here in this one, I've got K minus 8 times K minus 10 over 5 times K minus 10. So the K minus 10s in the numerator and the denominator, those can both cancel out. And I'm left with K minus 8 over 5 as my simplified expression. In number 6, I've got two rational expressions and they're being multiplied. Again, though, first thing I want to do is factor. So I'm going to start with n squared plus 9n plus 14. N and n, and let's see, 14 would be 2 times 7, and I need them both to be positive. And then in my denominator there, just have n plus 7. There's nothing I can do to simplify that. In my other fraction, n plus 5, and then in the denominator, this can be factored in and n, 1 and 2, and they're both going to be positive. So I'm looking for common factors that I can cancel out. I've got an n plus 2 in the numerator and in the denominator. I also have an n plus 7 in the numerator and in the denominator, so those can cancel. And I'm left with n plus 5 over n plus 1. Alright, number 7. Now this one, I've got two rational expressions, and they're being divided. Remember, when we divide rational numbers or fractions, the process is that we're going to multiply by the reciprocal. So I'm going to rewrite this as a multiplication problem, as a product, and while I rewrite it, I'm going to take a first step in factoring as well. So for the 4n minus 18, the only thing I can do to simplify that is factor out a 2. And so I get 2 times 2n minus 9. Down here in this denominator, they've got a negative in front. Personally, for factoring, I like my first term to be positive. So I think as a first step here, I'm going to factor out the negative. Now you don't have to do that, but for me, I just think it makes it easier to factor. Alright, I'm changing the division to multiplication, and then we're going to do the reciprocal of our second rational expression. So 6n squared minus 30n, that's going to go to the denominator, and I'm going to factor out as 6n. And so I've got 6n times n minus 5. And then the 14n squared minus 74n plus 20, we're going to factor that. And let's see, to get 14, I'm going to try 7n and 2n. And for 20, you know what? I think I'm going to factor out a 2. Let's go back. I'm going to factor out a 2 first. Make that a little simpler. Everything there is divisible by 2, so 7n squared minus 37n plus 10. That'll make the factoring a little simpler. Let's go on to the next step. So I've got some more factoring to do. This quadratic here can be factored, and this one also. So let's do that in the next step. My numerator here, 2 times 2n minus 9, is going to stay the same. Negative, but then I'm going to factor this. So 14n, whoops, sorry, I was trying to move my screen. 7n and 2n, I'll try that, and then 18. Let's see, if I put a 9 here, I get 7 times 9 is 63, and 2 times 2 is 4, and 63 and 4 does give me 67. I need them both to be negative so that the 18 is positive and my 67 is negative. And then here, my denominator, there's nothing else I can do there. But in the numerator, I've got the 2 out front, but now we're going to factor this, and 7n and n. And then for 10, I think I'll do 2 and 5. 7 times 5 gives me 35, plus 2 would be that 37. But I need them both to be negative so that the 10 is positive and the 37 is negative. Again, if you need to review factoring, there is a separate video on factoring quadratics. So now I'm looking for things that I can cancel out. I've got 2n plus 9 in the numerator and the denominator, 7n minus 2 both places, n minus 5 both places, and let's see, I can cancel that 2 with the 6 and make it a 3. So it looks like I'm just left with 2 over negative 3n for my answer. Next question. Now here we're adding rational expressions. And again, I think a good step is to factor, but ultimately we're going to need to get a common denominator so that we can combine these together. But let's go ahead and factor. So I've got 5 over k minus 3 plus k minus 4 times 6k times k minus 6. All I can do there is factor out a 6k. So now I'm ready to get a common denominator. I've got 5 over k minus 3, and I need to multiply that times 6k times k minus 6 over 6k times k minus 6, multiplying the numerator and the denominator by the same thing. And then over here, I'm going to multiply this fraction times k minus 3 over k minus 3. Alright, so in my numerator here, if I multiply, let's see, 5 times 6k would be 30k times k would be 30k squared minus 180k. And then over here, I'm going to put those in parentheses because they really are separate factors. And I need to multiply all this out. So plus, let's see, k times k would be k squared minus 3k minus 4k plus 12. And this is all going to be over the common denominator. And there's no need to multiply out the common denominator. The reason that we multiply out the factors in the numerator is so that we can collect like terms. So we can actually combine the numerators together. But the denominator can stay in its factored form. So let's see, if I combine like terms here, I get 30k squared. Oh no, I'm sorry, 31k squared. Minus, let's see, 180 minus 3 minus 4, so that's negative 187k, and then plus 12 at the end over our denominator. And that would be our answer. So here on number 9, subtracting rational functions. So again, I need to get common denominators. So I'm going to multiply 4 over 2 times x plus 5 over x plus 5. No factoring that needed to be done on this one. We're just going to go straight to common denominators. And so this fraction I'm just multiplying times 2 over 2. So if I multiply these out, let's see, I'm going to put these factors in parentheses, make sure that we do our math correctly here. I'm going to distribute the 4 to x plus 5, and so I get 4x plus 20. And then 2 times 2, of course, is 4, so minus 4, over 2 times x plus 5. And if I combine like terms in my numerator, I get 4x plus 16 over 2 times x plus 5. And if you got to here and stop, this is an okay answer, but really we can simplify this a little more. I can factor out a 4 in the numerator. 4 times x plus 4 over 2 times x plus 5. And then we can simplify the 4 over 2 and just make it 2. So I've got 2 times x plus 4 over x plus 5 as a final answer. All right, last problem. In this question, we actually have an equation, and we need to solve for b. And whenever I've got rational functions in an equation, if I'm going to solve it, I need to simplify things down to where I have just one rational function on either side of the equal sign. And so the left side here is okay. B minus 1 over, and you know what, I think I'm going to go ahead and factor that because it might be helpful to us later, equals, but here on the other side I've got a subtraction problem. I need to combine this together to where it's just one rational expression. So I need to get a common denominator, which means I'm going to rewrite 1 as b over b minus 5b minus 10 over b. Now we've got to be really careful at this step because this minus needs to be distributed to the 5b and the negative 10. So I've got b minus 1 times b over b minus 4 is equal to b minus 5b plus 10. So that's really important. The negative sign here, it has to go to the 5b, but it also has to go to the 10. We've got to distribute that to both terms there in that numerator. And all this is over b. And I'm going to go ahead and let's do one more step here. I'm going to combine the like terms in the numerator on the right side. So if I do that, I get negative 4b plus 10 over b. Okay, so now that I've got a rational expression on both sides, we can multiply our denominators to the other side. So I can take b times b minus 4 and multiply it over to the right side. And then I can take b and multiply it over to the left side. So we're going to do that. B times b minus 1 is equal to b times b minus 4 times negative 4b plus 10. So I've just multiplied my denominators. So now if you notice, on both sides of the equal sign, I have a factor of b. So I'm going to divide both sides by b and cancel that out. And I'm left with b minus 1 on this side. On the right side, I need to multiply this out. So b times negative 4b would be negative 4b squared. B times 10 plus 10b. Negative 4 times negative 4b would be plus 16b. And negative 4 times 10 minus 40. So now if I'm going to solve for b, notice I've got a quadratic here, and anytime I have a quadratic, in order to solve, we need to factor. And if I'm going to factor, I need to get everything on one side because I want to have it equal to 0. So I'm going to move everything over to the left side, and I get 4b squared. And then if I have 10b plus 16b, that's 26b. And if I subtract that over to the other side, then I get negative 25b, because 1b minus 26b would be negative 25b. And then the 40, I'm going to add to the other side, and I get plus 39 equals 0. All right, so now we need to try to factor what we have. And I think I'm going to start with the 39 because the only factors of 39 I can think of are 3 and 13. So let's see, to get 4, 1 and 4, if I do 1b and 4b, that's going to work because 1 times 13 is 13, 3 times 4 is 12, and 12 and 13, they do add to give me that 25. I want the 39 to be positive, but the 25 to be negative, so these are both negative, or both subtraction. And so now we can solve for b. We're going to solve by setting each one of these equal to 0. If b minus 3 equals 0, then b equals 3. That's an answer. And then if 4b minus 13 equals 0, then b equals 13 over 4. Now, what we should always do when we're solving an equation is go back and look at our original expressions and think about numbers that are not even included in the domain. If I think about my first denominator here, b times b minus 4, anything that makes that denominator 0 is not even included in the domain for this problem, which means b can't be 0 and b cannot be 4, because both of those things make that denominator 0. On the right side, my only denominator is b, and we've already got that listed here. B can't be 0. So b can't be 0 or 4. But we didn't get either of those answers anyway when we solved for b, and so both of our answers are acceptable.